Hello everybody and welcome. It is December 21st, 2023 and I am the Shy Hat. Today what we're going to do on this live stream is we're going to go through day 21 of TryHackMe's Advent of Cyber 2023 event. I'm going to leave a link to the event's webpage in the chat for you if you want to join in. The event is free to participate in. All you need to do is have a TryHackMe user account. It doesn't need to be paid. So today, what we're going to do is we're going to go through this DevSecOps challenge in the Advent of Cyber event. All right, without further ado, let's dive right into it. The first thing you want to do when we come into this challenge page, I'm going to make this a little bigger for us to be able to read this more easily, is we're going to click on this Start Machine button right here. So this is going to start the vulnerable server that we're going to interact with today. And so that while that is spinning up, we also need to start up our AttackBox VM. So the AttackBox VM is the virtual machine that we're going to be using to exploit the vulnerable server. We can do that. We can start up the AttackBox by clicking on this button up here, which is labeled Start AttackBox. So we click on that, and that's going to split the web page into two, with the left-hand pane being the TryHackMe web page, and the right-hand pane being the attack box, and it's going to initialize here for a little bit, maybe a couple minutes, but that gives us some time to read about what we're going to be doing today. So today, in today's challenge, let's read about the little backstory about what's going on inside of the storyline for the event, and let us begin. One of the main reasons for acquiring Antarcticrafts was for their crafty automation in gift giving, wrapping, and crafting. After securing their automation, they discovered other parts of their CI/CD environment that are used to build and extend their pipeline. An attacker can abuse these build systems to indirectly poison the previously secured pipeline. All right, so what are we doing in today's challenge? Our learning objectives are: understand how a larger CI/CD environment operates. Explore indirect poisoned pipeline execution, PPE, and how it can be used to exploit Git. Apply CI/CD exploitation knowledge to the larger CI/CD environment. All right, so this connection information here, we don't need to go over because we've already started the process. So let's talk about the CI/CD environment. Often developers or other end users only see a limited portion of the CI/CD pipeline. Developers interact with Git on a daily basis, so it makes sense that CI/CD is most commonly associated with Git, although it only makes up a quarter of the typical CI/CD pipeline. The diagram below visualizes the general segments of the pipeline: development, build, testing, and deployment. While these segments could be expanded and interchanged, all pipelines will follow a similar order. Okay, so we see that our AttackBox virtual machine has finished initializing. So we can click into this terminal window here and press enter to dismiss it. And we're going to make this, we're going to put the AttackBox VM in its own browser tab by clicking on this button right here, which is labeled View in Full Screen. So we're going to click on that, and it's going to open up a new browser tab. And in this browser tab, the AttackBox virtual machine desktop is going to appear. So we'll have one tab for the AttackBox virtual machine, and we'll have one tab for the TryHackMe webpage. So we're going to go back to the TryHackMe webpage, and then we're going to close out this portion of the this pane of the web browser window by clicking on this button right here, which is labeled Exit Split View. So it's down here. Click on that, and now we get our full screen back on our TryHackMe webpage. So I'm going to scroll down. and we were looking at the CI/CD pipeline. Okay, so we have development, build, testing, and deploy. So these three segments right here are part of the CI cycle, and this one right here, deploy, is part of the CD cycle. So CI is continuous. I'm not completely sure, but CD is continuous development. But all right, let's move on. In the previous task, we look at a CI/CD environment that was self-contained in Git. In a more formal environment, segments of the pipeline may be separated out into different platforms. Below is the CI/CD environment we'll be exploring in this room. You will notice the addition of Jenkins, a build platform and automation server. In the next section, we will explore Jenkins and discuss how these components interact and contribute to the pipeline. Okay, so here we have a diagram here. We're going to use git t, and that is integrated with Jenkins, and Jenkins is going to be deploying its Jenkins agent to build out the project. Okay, so let's talk about automation platforms. Jenkins, along with many other applications, handles a pipeline's build segment. These platforms can be remote or local. For example, Travis CI is a remote build platform, whereas Jenkins is a local automation server. These platforms rely on runners or agents to build a project on a pre-configured VM. One advantage of some automation platforms is that they can automatically create and configure build environments on demand. This allows building and testing in different environments without manual configuration or administration. So this is the main topic for today. It's indirect poisoned pipeline execution. Let's briefly shift our focus back to the development stage. In the previous task, poisoned pipeline execution was introduced, wherein an attacker has direct write access to a repository pipeline. If an attacker doesn't have direct write access to a main protected or branch protected repository, for example, it's possible that they have write access to other repositories that could indirectly modify the behavior of the pipeline execution. If an environment is employing a development pipeline, a configuration file must be defined for the steps the build system must take. If a repository contains all the necessary source and build files, and another repository contains the pipeline files, write permissions could differ between the two, resulting in an indirect PPE vulnerability. In this example, you can assume that the repository containing the source is not write protected, and the repository containing the pipeline is write protected. To exploit this vulnerability, an attacker would need to identify a file or other parameter they can arbitrarily change that the pipeline file will use. Makefiles and other build files are usually exploitable because they are used to build the source and can run any arbitrary commands as defined in the makefile. Below is an example of what this might look like in a pipeline file. Okay? So stage, make, steps, build. This is a function here, build, and it is sh shell make, and this is or true, make or true. To weaponize this vulnerability or PPE in general, the CI/CD environment as a whole must be taken into consideration. For example, if a build server is used to build artifacts on a pre-configuration virtual machine, an attacker could run arbitrary commands in that environment. Okay, so we come upon our practical challenge. Now let's apply what we've learned in this task, the Antarcticraft CI/CD pipeline. So navigate to this URL right here, which is the Git platform Antarcticraft uses for version control and development. Okay, so what we're going to do is we're going to copy this URL right here, and then in our virtual machine, our attack box, we're going to click the attack box, and we're going to open up a web browser within the attack box. So we can use this browser, this shortcut right here, or this shortcut right here to open up the Firefox web browser. Okay, and inside the web browser, we can click on the URL address bar and paste so that this URL appears. Okay, and then we see Antarcticraft's Git webpage right here. All right, so let's go back to the TryHackMe webpage and look for further instructions. The Git platform Antarcticraft uses for version control and development. Log in using the credentials guest as the username and password123 as the password. When you have logged in successfully, you should see two repositories, gift wrapper and gift wrapper pipeline. Okay, so what we're going to do is we're going to go back to the attack box and we're going to click on inside of the web page. We're going to click on sign in, which is right over here in the corner. And we're going to use the username guest and the password password123 as indicated in the web page, in the TryHackMe web page. Click on sign in over here. And we see that we have two repositories inside of here. We have the gift wrapper pipeline repository, and we have the gift wrapper pipeline. All right, so we go back to the web page and we get some further instructions. Once you have logged in successfully, you should see a project, gift wrapper build. Okay, so we saw this on the attack box page there. Before looking at the environment's other components, let's dig deeper into Git repositories. So looking at the gift wrapper pipeline repository, you may notice a Jenkins file. If a repository is unprotected, an attacker can modify a pipeline file to execute commands on the build system. For example, an attacker could control the build stage by modifying make or true to who am I. This is possible because the Jenkins file allows you to run shell commands, as you can see on line 13. This is an example of PPE as covered by the previous task. Okay, so in the attack box, let's see, which one are we looking at? Gift wrapper pipeline. So we click on gift wrapper pipeline. Okay, and inside of gift wrapper pipeline, we see a file here that is labeled Jenkins file. So we can click on that, and we see that there is a bunch of code over here. And the line that they mentioned in the on the web page is this line right here, which is executing shell make or true. I think I can make this this text a little bigger for us. Okay, that's a little better. To modify the Jenkins file, we will use the power of Git. To begin working with the repository, a local copy must be created or cloned from the remote repository. In this example, Git is the repository site. Run the command below to clone the gift wrapper pipeline repository locally. Okay, so what we're going to do here is we're going to copy this command. We're going to copy that, and then we're going to go to our attack box, and we're going to close out, sorry, we're not going to close out, we're going to minimize our Firefox web browser window. Okay, and then we're going to open up a terminal window. So we can open up a terminal window with this shortcut, or this shortcut. And after we've opened up our terminal window, we can make it bigger. I'll make it bigger so we can all see better. And I'll make this a little wider. Okay, so now that we have our terminal window established here, I'm going to paste in the command that we copied from the TryHackMe webpage with Control-Shift-V. All right, so we're going to execute this command, and that's going to copy copy the files from the Git repository onto our attack box. So it says cloning into gift wrapper pipeline. All right. So if we do if we use our Linux command ls -la, we see that there is a file. There is a directory that's called gift wrapper pipeline that was created in our directory. Okay, so what we can do is we can navigate to that directory, cd gift wrapper pipeline. And remember, if you start typing in the name of a directory or a file, you can use the tab key to autocomplete. And if there are no other similarly named files or directories, then you should get the shortcut for spelling out that file or directory. Anyways, so cd is going to let us enter the directory, and then we're going to use ls again to see what's inside this directory, and there's just one file in here, which is the Jenkins file. So we can read the Jenkins file. I'm going to clear out the terminal so that we can get our text closer up to the top. I'm going to use the cat command on the Jenkins file to see what's in the Jenkins file. So here we see the code from the web page that we were looking at. All right, so let's go back to the web page, the TryHackMe web page, to get further instructions. Once cloned, we can make any changes we wish, then commit the changes. To start, we can exploit PPE by changing line 13 of the Jenkins file from sh make or true to sh who am I. When a commit is created, a snapshot of the current state of the project is saved to the local repository. To add our changes to the remote repository, we must push our commits. After modifying the Jenkins file, run the commands below to add, commit, and push your changes. All right, so we're going to run these three commands right here inside of our terminal to try to modify the contents of the repository and push them to the push them up to the repository. Okay, so the first one is git add, and that's going to add the current directory to the working Git directory. Okay, so git add and then git commit. Oh, what I forgot is that we're supposed to change this command right here to this command right here. So I'm going to do that really quick. Okay, so we're going to use so we need to modify the Jenkins file over here. So we're going to use the nano text editor to modify the Jenkins file. So we use the command nano Jenkins file. And what we're going to do is over here on line 13 is we're going to modify this command right here from sh make true to sh who am I, which would return the username that is executing the commands. Okay, so so this is command we're supposed to modify. So what we're going to do is we're going to save this out. We're going to save this file using Control X, and when asked to save the modified buffer, press Y, and then press Enter to confirm. Okay, so we're in the middle of adding this to the repository using Git. So we did git add to add this directory to, well, let's do that again. So git add period. Okay, and then the next one is git commit. So commit is going to confirm that we're trying to modify the repository. And the -m means that we can insert a message when we make our commit. And I'm going to do testing. I'm going to do please like and subscribe. Okay, so that is the message. And then it says one file was changed, 2 insertions, and 2 deletions. Okay? And the last command we're going to do is git push. So git push is going to try to modify the repository using the files and the changes that we've done locally. So we're going to copy that command and we're going to paste it in using Control-Shift-V. All right, so we're going to use the same username password that we were given before. So it's guest and password 123. Okay, but the problem is that we receive an error here from Gitee. User permission denied for writing. Okay, so this user account can't do any writing. Doesn't have the proper permissions to write up to the repository. So let's take a look at the web page to see what we can do. When attempting to push changes to the repository, you'll notice that it's main protected. You can also try creating a new branch, but you will notice the repository is branch protected too. This means we must find another way to indirectly modify the pipeline. Looking at how the Jenkins file works, you may notice that it uses make. If you recall from the previous section, a make file can be a defined set of rules to execute steps, such as commands. The make file is defined in the gift wrapper repository, meaning it could have different protections from the pipeline repository, and an attacker could add malicious commands to it. After also cloning and attempting to push changes to the gift wrapper repository, we see that our commit is successful. Depending on the configuration of the build system, different actions may initiate a new build. In this example, we have access to Jenkins, so a build can be manually scheduled by pressing the green play button. Okay, so what we need to do is we need to poison sorry. I'll explain this when I go over to our web browser. So inside of the attack box, let's open up our web browser again. And we're going to go back. So we have 2 repositories inside of here. So we have a gift wrapper pipeline repository, and we have a gift wrapper repository. So the gift wrapper pipeline repository is the main repository, but it makes use of the gift wrapper repository. So if we click on the gift wrapper repository, and we see the make file over here, we remember that the make file was mentioned in the Jenkins file inside of the pipeline repository, and we also have access to the gift wrapper repository, which is part of the gift wrapper pipeline repository. So what we do is we go up a level and we modify a file inside of the gift wrapper repository, which will also affect the gift wrapper pipeline repository and allow us to poison the pipeline indirectly. Okay, so how do we do this? So what we can do is we can, just like the previous gift wrapper pipeline Git repository, we can copy the gift wrapper repository to our local machine. So what we do is we're going to use the command that we used for, so git clone, we're going to git clone the gift wrapper repository. So we're going to copy this up until gift wrapper, and then we're going to go to the terminal, and I'm going to clear this, and we're going to go to the previous directory, cd ... and then we're going to paste in the command here, git clone, not the gift wrapper pipeline repository, but the gift wrapper repository, and we have to remember to add .git to the end of this command right here. So we copy this, and it's going to clone into gift wrapper. So we have to enter the directory cd gift-wrapper. Okay, and we're going to list out the files in this directory. And we have the make file here. And the make file is incorporated into the other repository, so we can modify this one. And how do we do that? We're going to use nano again. Nano makefile. Okay, so this is part of build. What we can do is we can modify this the current file, which is executing the pip script, and instead we can do something like who am I, and that's going to execute the who am I command. So we're going to save this by using the Control X shortcut. Press Y, press Enter. All right, and then we're going to do the same steps that we did for the other repository, which is git add period, which is going to add the current directory, and then we're going to do git commit -m, and then inside of quotes we're going to add the commit message, which is adding who am I command. Okay, and then we're going to press enter to execute that command. It says 1 file changed, 1 insertion, and 1 deletion. Okay, and then we're going to do git push, and git push is going to upload the modified file up to the repository. And it's going to ask for the username. Remember that our username is guest, and our password is password123. Okay. All right. So it was adjusted. Nice. Well, that's what it says. Let's go back to the web page here. Okay. So, looking at how the Jenkins files works, you may notice that it uses make. If you recall from the previous section, a make file can be used to define a set of rules to execute steps, such as commands. The make file is defined in the gift wrapper repository, meaning they could have different protections in the pipeline repository, and an attacker could add malicious commands to it. After cloning and attempting to push changes to the gift wrapper repository, we see that our commit is successful. All right, so we can check the status and output from the build from Jenkins by navigating to this URL right here. So copy this URL, and then go back to the attack machine web browser, and we're going to make a new tab here. And then we're going to paste in the address we got from the TryHackMe webpage. Okay, and this is going to drop us on the Jenkins login page. If we go back to the TryHackMe webpage, within the project gift wrapper build, okay. Sorry, they were supposed to mention, they mentioned somewhere that the Jenkins platform that Antarcticraft uses for building and automation is, they use the credentials admin and admin. Okay, so we're going to go back to the Jenkins webpage, and we're going to log in using the username admin and password admin and sign in. And this is taking a little bit of time. Okay, so let's go back to the web page to see. Okay, so we have to use the gift wrapper pipeline repository here inside of Jenkins. Gift wrapper. So we click on gift wrapper. Wait, let me check again. Is it gift wrapper? Oh, no. It's the gift wrapper pipeline. So we're going to go back, and then we're going to click on right. So inside of gift wrapper build, there's gift wrapper pipeline. So we're going to click on that. And then we're going to click on main. And then we can click on the build now button right here. Okay, so we see that there's been a commit right over here on December 21st, which is today at this time, and this is our poisoned commit right here. So this commit is being executed right now, and it takes a little bit of time to execute. Just have to be patient. Okay, so while we're waiting for this, oh, it looks like, okay, so it's working now. Okay, and I think it's going to finish up in just a couple of seconds. Okay, so it finished building that. What we can do is we can take a look at, we can click on the latest build, which is number 3. And then we can click on the console output to see what the machine is doing. Okay, so if we scroll down here, we see that there are a bunch of commands being executed, and we see that we see our commit message that we added here. The commit message is adding whoami command. So we see here that the whoami command that we put inside of the makefile was executed, and we see that the username being provided back is Jenkins. So that means that our indirect poisoning attack was successful. All right, so this is where we've come to the end of today's challenge. But we have to answer a few questions before we finish out the challenge. The first question they ask is, what Linux kernel version is the Jenkins node? So all of these questions here we can answer by providing poisoning attacks to the pipeline and getting Jenkins to run those commands. So what Linux kernel version is the Jenkins node? If we click on the hint, it'll tell us that we have to use the command uname-a. All right, which means that we're going to go to our attacker machine. We're going to minimize our web browser, and then we're going to modify the makefile again. So we're going to do nano makefile, and then instead of whoami, we're going to insert uname-a. And then we're going to Control X to exit, save our changes. And then we're going to do all the steps that we did previously. So it's git add period, git commit -m, getting kernel version info. Okay, and then we're going to git push. So once again, guest is the username and password 123. All right, so that means that we should have, in Jenkins, we should see a fourth commit. So if we open up the web browser, we're going to click on here, main, and then we're going to click on build now. And we see that a commit number 4 has been added here. Okay, and it looks like it's already executed, which is good. Then we can click on build number 4, and then we can take a look at console output. Okay, and we see our commit message here, getting kernel version info. And then we can see the uname-a command being run right here. And the answer we're looking for is this version number right here. So this is the version number of the Linux kernel, 5.4.0. Yeah, this one right here. So we can copy that, and then we can supply that as the answer on the TryHackMe webpage. Okay, so here we're going to paste it in, and we'll click submit, and we see that that was the answer. And the last question is, what value is found from this directory right here? So var lib jenkins secret.key. So we can find this answer by poisoning the pipeline one last time and using the cat command. So what we do is, inside of the attack box, we're going to minimize the window again, and then we're going to nano the makefile again. So nano, and here, instead of uname a, we're going to do cat, and then we're going to copy the directory name from the TryHackMe webpage. So var lib jenkins secret.key without the question mark. Copy that, and then in here, in the attack box nano window, paste, and then save it out with Control X, Y for yes, enter to verify the name, and then we're going to do all of our git commands again. So I'm going to clear. So the git add dot, and then git commit -m, and then what is this? This is getting the secret key as the commit message. Okay, and then git push. We supply our username, and then we supply our password. Okay, all right, so then we have to go to our attack box web browser, and we go back to main, and then we click on build now. Okay, so it is building. Okay, it says one commit, and the commit message is getting the secret key. All right, so this is number 5, so we can click on number 5. We can click on console output, and inside the console output, we see our commit message getting the secret key, and we see the command here, cat var lib jenkins secret.key, and this is the key that we have to provide for the answer in the TryHackMe webpage. So copy that, and then go back to the TryHackMe webpage, paste this in, and click submit. And for the last question, we just have to click completed. All right, so everybody, in today's challenge, what we did was we accessed the Git files, the Git repository files for a production CI/CD pipeline, and we were able to poison part of the pipeline, which influenced the rest of the pipeline and allowed us to run arbitrary commands on the server. And so that's an example of DevSecOps. I hope you learned something. I hope you learned something good from today's challenge. I know I did. And we'll be back tomorrow for day 22 of the TryHackMe Advent of Cyber event. This is the Shy Hat, and we'll be back tomorrow. Until then, have a great day, and we'll see you next time.